This video is going to cover something called multiplying a monomial with a polynomial. And before Wyatt or Cameron ask me, this is a very math-specific skill. This lesson and the next lesson are really helpful as we get back into some real-world skills, but it is incredibly important that we understand that this is not going to be a super real-world topic. There's not even going to be really story problems that make a lot of sense in the next section or two. Now, this term or the description of the video is very vocabulary heavy, so let's review the vocabulary from last time. If we look at each of these terms, they have a prefix that kind of tells us what we're working with. For example, monomial would be one term. Binomial would be two terms. And then polynomial would be many terms, or variables in a lot of cases. So as we're working with multiplying a monomial with a polynomial, the goal of this video is to multiply one term times a bunch of other terms, which means we're going to be using the distributive property a ton. And if you come up and talk to me right now and explain to me what the distributive property is, I will give you 5 SPs. I almost didn't have a pun in this video. I was really nervous about it, and then I remember how much my students love those, so I made sure to get those in. As a quick review of the distributive property, what we usually do is we think about this number on the outside, and it's distributing to each individual number in the middle. And the reason why we're doing that is the distributive property really means this term 4 or 3 times. So this is really what the distributive property is, but very, very rarely are we actually going to write it out like this. Instead, we would write 3 times x is 3x, and 3 times 4 is 12, and that would be our distributive property. But if we notice over here, we get x plus x plus x is 3x, 4 plus 4 plus 4 is still 12. And so thinking about the distributive property in this context or this context doesn't really change the problem until the thing outside of the parentheses is no longer a regular number. And this is what the lesson here is going to cover. So if I have x times 2x right here, what that would mean is what we're really doing is 2 times x times x. But if we have the opportunity, we would never write it like this. We would write 2x squared, because x times x is x squared. Then we are going to multiply x times 6, which is positive 6x. Positive 6x. And because we are just simplifying, we now are actually in simplest form because x squared and x cannot be combined, and we covered that in the last video. So as we get to a problem that's slightly more difficult, we have y times 2x, and this is where it's a little bit different, because before we couldn't combine y's and x's. Here we're not combining them, we are multiplying them together. So y times 2x is actually just going to be 2xy, or 2 times x times y. Then if we distribute our y to the 6, just like up here, we get positive 6y. Now, the variable xy, if we think of this as one singular variable, is different than the variable y or the variable x, which means this term and this term cannot be combined, so we are in simplest form. And right here, this is what the lesson is covering, multiplying a monomial times a binomial or polynomial. So let's do another example. We're going to kind of keep ramping up the difficulty here. For this problem, we have 2x squared, or we can think of this as 2 times x, and we multiply that times 3x. Well, 2 times 3 is 6. X squared times an extra x gives us 6x cubed. which is really just adding the exponents of 1 and 2 together to get 3 x's total being multiplied together. Now we are going to multiply 2x squared times y, which is, first of all, the numbers 4 and 2 multiplied together to be 8. X squared looks like this, and then times y. We cannot combine the x's and y's together, so we are simply left with x squared times y. X cubed, and then x squared times y. This variable and this variable are different, so that means we are done with this problem, and we are in simplest form. To get a little bit trickier, we now have negative 3a times the binomial 2b minus 14. Once again, we can distribute to both terms. Negative 3 times positive 2 is negative 6. A times b is just ab. We cannot combine them any further than that. Then finally, we have negative 3 times negative 14, if we think of this as the whole term here. 14 times 3 is 42, and that would be a positive 42a. The variable ab is different than the variable a, and therefore this cannot be combined. Let's do one final problem here. Now this looks pretty tough. We have a monomial right here, one term times the polynomial right here, 3 terms. So this is exactly what the video is trying to cover, a monomial times a polynomial. So this is as hard as we can get. But the process is going to be exactly the same. We distribute to all 3 terms instead of just 2 terms. We could do this 4 times, 5 times, 6 times, whatever, but the process is the same. So we're going to do 5g squared times 3g squared, which is going to be 15, and then g to the 4th, because we have 2 g's here, 2 g's here, combines together to be 4 total g's. We have 5g squared times 9gs, which is a separate variable. So we get positive 45 g cubed, because there's 3 g's, and then the s is left over. S can't combine with anything else. And then finally, our final answer is going to be 5g squared times 6s squared, which is 30. G squared doesn't change. S squared doesn't change. And we are now in simplest form. So this is a very math-specific skill. As always, if you have any questions, please let me know.